Welcome again to Let's Talk Advanced Chemistry, Chemistry 2. We're looking at acids and bases here. And we began looking at the introductory, what we talked about last year. Today we're going to look at Ka and Kb, the way of determining the concentration of weak acids and bases. Now we do that through the values of equilibrium reactions. When they're weak, they're equilibrium reactions. We use the values of Ka and Kb. Ka is if it's an acid and Kb if it's a base. So let's try this first one, pretty straightforward. We're going to find the Ka, find the equilibrium product constant for acids, the acid equilibrium product constant. For a chlorous acid, if at equilibrium, the acid concentration is 0.002567 molar, and the pH is 2.189. So we're taking things that we looked at before and want to put them together to make this work. So first we need to know what acid is, and it's chlorous acid. Us acids are ites, so therefore that's HClO2 chloride. H is plus, chloride is minus, and because 2 minus 1 is 1 that's less than 2, so it's going to be equilibrium. Now we dissociate it into its base ions, so it's hydrogen and ion. So my Ka value is going to be the products over the reactants, and because everything's 1, my exponents are all 1. The concentration of H plus times concentration of ClO2 minus all of the concentration of HClO2, and that's going to equal our, we want to find hydrogen ion first, mea culpa. We do that by taking 10 to the minus pH we talked about yesterday. So therefore, if we take 10 to the minus pH, 10 to the minus 2.189, the hydrogen ion concentration then is 0.006471. Put in your calculator and get your answer. All right, now, we know that the hydrogen ion concentration, 0.00676471. But if you look up here, hydrogen ion and chloride ion are 1 to 1. So if 0.006471 is concentration of hydrogen ion, it's also concentration of chloride ion. So we can just say that it's 0.006471 squared because of the same number. From the problem, we see the concentration of the acid is 0.002567. So if we take our calculator, 0.006471 squared, equal divided by 0.002567, we get a Ka value of 0.01631. So it's reactant favoring, we have less products. All right, straightforward, shouldn't be too bad. Let's try another one. Explanation here. When acids dissociate, they do that monoprotically. What does that mean? Well, let's take an example of, that means one hydrogen ion at a time. Okay, so let's take the example of phosphoric acid. When there's 3 hydrogen that have to come off of that. So we have, it's a weak acid because 4 minus 3. So at equilibrium, we're going to get H plus H2PO4 minus. So we're going to lose 1. And that's going to give us our own Ka. That's we call that Ka1. Now this H2PO4 can also dissociate in equilibrium because 4 minus, we just continue the process. And so it's going to be H plus HPO4 2 minus. We're not going to worry about the fact that it's 4 minus 2 because the process has started. And once we get that one, we could do a third one. That's Ka2. We can get Ka3, of course, down to the phosphate molecule. Hopefully that makes sense. We're only going to do Ka1s. We're not going to move beyond that, or I'm going to get reactions where you only have one. But know that does exist. All right. Now, we can also find the pH. We can find values from that given the Ka. So let's do a problem here. Find the pH of 1.225 molar acetic acid. That's at equilibrium. If the Ka is 1.8 times 10 to the minus 5th. All right. So acetic acid, acids are 8s. That's acetate, C2H3O2, hydrogen 1, acetate 1. 2 minus 4 actually is way less than 2. So it's also equilibrium and dissociate, you get H plus C2H3O2 minus. So our Ka expression is the concentration of H plus times concentration of acetate all over the concentration of H2CO3. It means there's a multiple on top. All right, and that's equal to 1.8 times 10 to the minus 5th. Now we're not going to worry about this. This is like comes off of a chart. So we're not going to worry about this as sig figs. We're going to look at 1.225 for sig figs. We don't know X. We don't know it's a hydrogen ion or acetate, but we do know the acid concentration. Okay, so X times X is X squared, and the acetate concentration 1.225. So we're going to solve up, multiply up, and then take the square root of both sides to give us X. X, which is going to be 0.00002205, is going to be my hydrogen ion concentration because that's X. So if all I have to do is plug it in for pH, pH is negative log of hydrogen ion concentration, pH is negative log of 0.00002205, and that's going to give us 4.657. That's our answer. All right. Now, one last one. This goes back to what we did before to find the concentration of all. So this is going to be a start, react, equilibrium. Exactly the same. We're going to do for a Kb of 4.8 times 10 to the minus 20th and a starting base concentration of copper 2 hydroxide. So take copper 2 hydroxide. It's going to be weak, so we're going to do the dissociate into its ions and then do the whole start, react, equilibrium. Pause the video, work through this like we did before. Any questions, ltswpd@gmail.com. Remember, like, subscribe, share. Any questions, let me know. Comment, and I'll try to respond back. Okay? Here we go. All right. Here's all the work. And those are the concentrations. And that's my X value. All right. Not too bad. Hopefully we got this. Take care. God bless. Bye.